So today we're going to talk about abstraction and pattern identification. The idea of abstraction and pattern identification is, well, first off, it's abstraction, but secondly, which we'll discuss in a little bit, and secondly, it's just finding patterns that allow us to make our programs more efficient. All right, we've discussed this algorithm before, the metric that shows fill-in-the-blank pattern identification. So we fill in the last number, divide that number by 2 to get a result, add 10 plus 1 to get a sum. You can see this 10 is occurring more than one time. And for that reason, this is a pattern of like a fill in the blank. You can turn this into a variable. And by finding that pattern, you're finding similarities in procedures and tasks that allow you to abstract things in a better way. There are repetitive patterns. If something happens more than once in a program, you might want to do a method call and probably an iteration. There's classification patterns where you can find similar attributes that might be able to put things into one object class. The Maze Your Friends algorithm uses a fill-in-the-blank pattern. The blank line is the abstraction that can be turned into a variable. Now, the definition of abstraction is hiding details, simplifying complexity, or substituting a generalization for something specific. It allows an algorithm to work with multiple inputs. So just because we use 10 in the example doesn't mean we have to use 10 in the algorithm. We can pass it in as a parameter. This is a key element of computational thinking. When it comes to like your car, which is its own kind of computer, when you turn on your car, all of the processes that cause that car to initiate are abstracted from the user. All we know is we turn the key. The electronic fuel injectors fire off. The spark plugs fire off. The computers do their test. And all those things happen without us realizing it. That's an abstraction. The ignition switch itself abstracts all the other details that allows the user to utilize that car effectively. A stand-in name for the blank, in this case, such as last number, is an abstraction. So realized variables are the beginning kind of abstraction we work with, but to be fair, numbers themselves are abstractions of a larger process or larger characteristic. Numbers represent the idea of numberness, that two boats and two cars have a similar property of two-ness. And so we use the number 2 to show that abstraction. All right. We can also talk about abstractions as classes and objects. For example, social media can have login credentials. That can become a template. That template would be its own class, and the attributes would be the things you need to type in to log into social media. That class is formed by abstracting away details from any specific subscriber. Now, when we talk about abstractions, we have to dig into the idea of black boxes. I mentioned earlier the car scenario. When you turn ignition in a car, there's a lot of things that happen that the user doesn't have to know about. We don't need every user to understand every detail of the car to operate the car safely and efficiently. We only need the user to be able to turn the key. We hide that in a black box so that something is easier to use, so that the complex processes are made simpler so that more people have access to that technology. Programming languages have these structures that allow us to develop what's called a black box, a fundamental algorithm or process that the complexities are hidden from the user. And it looks like this. The input goes in, processing happens inside. We don't see the processing, but something comes out. Now, as a developer, you're coding that process, but honestly, you don't really know. The user does have no idea how complicated that process is on the inside. When we open up script for a game to a user, they don't realize all the complexities that go into it. It's a black box. And what it kind of looks like is this. We type in a password. The program looks up the stored user ID and password, compares the stored user ID and password to the entered user ID and password. If they match, allows access. Allow or deny access happens on the other side. The user sees the user ID entered and access being allowed or denied. The user does not see the rest of this process because that's hidden, concealed within the black box. This is the concept of abstraction. A level of abstraction relates to the amount of detail that is hidden. Abstracting out too much, I'll say it this way, abstracting out too much detail makes a program too generalized. And I'll show that visually in a little bit. Neglecting abstraction produces programs too specific to work with a wide variety of data. The idea is this: if I have to have my user, pour in their own gas and make their own fire, the car is pretty inefficient. But allowing the ignition switch to happen makes it much easier to handle. If we abstract out too much, a user might not know how to turn the car on at all. And to give you a visual of how that looks, here is a heart. This left side, if you're trying to say, hey, it's Valentine's Day, be my Valentine, the left side might be a little too gory for the average user. The middle is just about right, but the right side, imagine sending this to your Valentine. Would they even know what you were talking about? So we try to get our abstraction just right. And when abstraction is handled just right, we have just the right amount of work to allow users to handle things effectively. All right, we are going to stop the recording here. Since my screen went black.